This is the first video on section 3.4, quadric surfaces. And so definition 85 gives the 6 types of quadric surfaces that we look at, and each one of those can be oriented another way. So each one of those equations can be written in 2 additional ways, and so I'll talk more about that in the subsequent videos. Right now what I want to do is I want to look at example 86. So we're going to take these objects and we're going to rewrite these, making one of the variables a constant. And so when we do that, we're going to see what this looks like in each of these planes. So for example, we start with x squared plus y squared plus 3z squared equal to 1, which is an ellipsoid, but we'll get to that a little bit later. When x is equal to k, so we set x equal to k, this is constant. I should say something else about this equation. We're looking at the set of all points that satisfy this equation, and of course not all points would satisfy this equation. So for example, if you took the point 1, 1, 1, that does not satisfy this equation because 1 plus 1 plus 3 does not equal 1. So we're looking at the set of all points that satisfy this equation. So we're making that same restriction when we substitute k for x. So when you substitute k for x, then we can rewrite this equation, x squared plus y squared is equal to 1 minus k squared. And this is an ellipse in the yz plane. Do a similar thing for y equal to k. Substitute k for y, we have x squared plus z squared is 1 minus k squared. This is also an ellipse. It's essentially the same ellipse as this, it's just in a different plane. So this first ellipse is in the yz plane, this ellipse now is in the xz plane. Finally, what happens when z is equal to k, we have x squared plus y squared minus 3z squared. Because these coefficients are equal, we have a circle. And so in the xy plane, or a plane actually parallel to the xy plane, we have a circle. So this is what a cross section looks like at x equal to z. So you take this cross section and you have a circle. Part B, we have 2x squared minus y squared plus 2z squared is equal to 1. When x is equal to k, we have 2x squared minus y squared equal to 1 minus 2k squared. This is a hyperbola. So you have something squared minus something squared equal to some constant. So this is a hyperbola. When y is equal to k, we have, up here, we have 2x squared plus 2z squared is 1 plus k squared. This coefficient and this coefficient is the same, so we have a circle. If we want to divide both sides by 2, x squared plus y squared is equal to something squared. So we have a circle. Finally, when z is equal to k, we have 2x squared minus 2y squared is equal to 1 minus 2k squared. It's very similar to this. We just have different variables, right? So it's a hyperbola. It's just a hyperbola in a different plane. Now, what I want you to do before you go on to the next video is I want you to go back to definition 85. I want you to study the textbook page or pages that has these. I believe in this textbook it's 1 page. I'm not going to specifically name a page of a textbook in case we ever change textbooks or change editions. So I won't name the textbook or the page number here. But I want you to study that page. And that will help you. Again, keep in mind, each of those equations, they're given one orientation. So many of those equations, you can write them 2 different ways. So you can write those equations in 2 different ways. And so keep that in mind, because some of the quadric surfaces we look at in the next videos, we're going to have those surfaces, but they're going to be oriented a slightly different way.